This is a lab where we were told to utilize reactance to step down the overall power of a 208 volt two-phase AC power supply to power a standard LED. For this lab, I decided to wire a single non-polarized capacitor in series with the input power. First, I started out by calculating how much reactance I would need from that capacitor to get me between 15 and 30 milliamps for the LED. I then selected an available capacitor with the closest values I could get, which was about 0.33 microfarads. After redoing the calculations for that specific component, I decided that the LED would still work. Here is our circuit and our schematic. You'll notice that there is a 1000 ohm resistor in the series with the LED and a 47 microfarad capacitor in parallel with the LED. According to the calculations, technically the LED would still work without the resistors. The reason we included the resistors is so that we can increase our smoothing factor, or attenuating factor. Based on this formula, to an extent, the higher the resistance, the better the smoothing factor will be. This is because the resistor will slow down the total discharge of the capacitor to prevent voltage spikes. The higher the resistor, the less severe the voltage spike from the capacitor will be. Since we were dealing with higher voltages, we decided to redo all our calculations for a lower 40-volt source, then test our circuit to see if it would line up with our calculations. After that successful experiment, I then plugged it into the 208-volt power supply, and it worked as predicted. As you can see, here is me powering on the circuit, and using the multimeter to measure the total circuit voltage. It may be hard to see here in the video, but we measured about 208 to 209 volts across that circuit.